Algebra 1, Common Core, Unit 6, Section 5, Graphing Inequalities. So before this, we spent the past several videos talking about linear equations and graphing lines and linear systems, talking a lot about y equals mx plus b and how do we find out where two lines cross graphically or find out where two lines cross algebraically using substitution or elimination. Well, now what we're doing is we're still kind of working with those linear models. We're still going to have a mx plus b, but it's not going to be a y equals mx plus b. We're changing the equation side of it and going to talk about inequalities. Now, inequalities are the symbols like less than, greater than, less than or equal to, greater than or equal to. And we've worked a little bit with inequalities before as like solving inequality equations. So the concept of inequalities isn't new to us. We know that if we have, 2x, plus 3 is less than 5, I know how to solve that inequality, and I could express it as a, interval notation, and I could draw it on a number line and things like that. Well, it's one dimension because there's only one variable here, x. That's why I could draw it on a number line. But if I had a y in there, then it'd be two dimensionals, and it would have to go on a xy axis, just like our linear equations do. Remember, if we have to divide by a negative, we're going to flip the sign and stuff like that. So we've talked a lot about these before. Graphing inequalities. So again, instead of having y equals mx plus b, we're going to have something like y is less than mx plus b. But it's not always less than. It could be greater than. It could be less than or equal to. It could be greater than or equal to. So there's really four options for an inequality. For an equation, it's an equal sign. That's why they're called equations. An inequality has an inequality sign, and there are four of them. Now, really, you kind of think just less than and greater than, but then you could put that equal to bar underneath them to make them or equal to. Remember my favorite way to remember which one's which is that, if you kind of rotate the L and squish it down a little bit, you get a less than symbol, L for less than, so that's how I like to think about those. Plus those less than arrows are pointing to the left, again, L, and the numbers to the left are less than the numbers to the right. So you have a couple of different strategies to help you remember what those symbols are. So as far as graphing an inequality, the big difference is when we graph a linear equation, we just graph a line. We have a slope, a y-intercept. We start at the y-intercept. We use the slope to go up 1 over 2 and just draw the line. Put some arrows on the ends, label it. That's it. And the solution set is everything that's on the line. Well, in an inequality, there's a little more going on. There's two major things. The first thing is you need to determine if it's a solid or dotted line. No, not crayons. Let's go with the highlighters. Solid or dotted. What you're going to see is there's some inequalities that are drawn with solid lines. This is the case. This is a case of a dotted line or a dashed line. And when our inequality sign is the greater than or less than without the equal to bar, we draw dashed lines from our slope and y-intercept. If it says greater than or equal to or less than or equal to, then we draw a regular line. But then it's not just that. It's a solid or dotted line. So sometimes it's solid like a regular line. Sometimes it's dotted or dashed. And then we need to shade. Kind of like when we had those number lines. If you remember when you graphed on a number line, x is, less than 2. That was, 2's down here. That'd be an open circle. That'd be like your dashed line. And then we draw an arrow to the left. Well, instead of drawing an arrow, we're going to shade part of the graph. And then if it's less than or equal to, we have a solid, a closed circle. That's what we talk about. Well, in this case, it would be instead of a dashed line, a regular line. But you still have the arrow, so you're still going to have to shade some things. So it's a lot like solving regular lines, but there are these two aspects of it could be a dotted line, and we're definitely going to have to shade a portion of the graph. So for the example here, and of course you could read this to help you understand this better. This paragraph here is a pretty good one because, how do we decide where to shade? For less than we shade below it and greater than we shade above it, but sometimes it's not always so clear what's above and below. So you could always use the y-axis. That no matter where your y-intercept is, the greater ones are above it and the less than ones are below it. But anyways, I'll go over that when we do some other examples. This one here, to graph this one, which is y is greater than 1/2 x plus 2. You start the same way you start lines. The slope is 1/2, the y-intercept is 2. So starting at your y-intercept, I made points of, up 1 over 2, up 1 over 2, up 1 over 2, and then we continue that pattern in the opposite direction until we run out of space. Now, where you're going to have to hesitate is you don't want to just draw the line, because that's what you're used to, is you have to make those dots to draw the line. For inequalities, you need to wait a second and ask yourself, is it a solid line or a dotted line? And because our symbol is just greater than, it is going to be a dotted line or a dashed line. If it were greater than or equal to, it would be solid. But it's dashed here because it's just greater than. Then the shading, because it's greater than, a greater than symbol. The greater than symbol tells us that it's dashed, but it also tells us to shade in the greater than direction. So you see all these shading lines are the part of the graph that's above it. I guess these got kind of in the shaded region, but no points on the dotted line. So these words are supposed to be kind of over here. Not sure how that happened. But anyways, so if this was the only change, if this was greater than or equal to, the only difference is this would be a solid line. If it were less than, we'd be shading to this side instead. So these are two steps here. This is, step 1 got us to the dotted. Step 2 is the shading. This is your final answer. This is what an inequality graph looks like. And you actually can do this in your calculator, but you have to change some settings in your y equals. Maybe you'll see that in class. So the other thing is, again, what I said was, when it comes to a linear equation, you just draw the line. All the points on the line are the answer. When it comes to an inequality, all of the points in the shaded region are in the solution. Now, when it's a dotted line, we do not include the points on the line. But if it's a solid line, we do. It's kind of like when you have, x is greater than 2. 2 is not in the answer. It's just the number's greater than 2. But if you say x is greater than or equal to 2, well, now 2 is in the answer. It's like now the point's on the line. So let's try a couple examples. So y is less than or equal to 1/2 x plus 3. So we begin just by, slope, y-intercept. So you're not really thinking about inequality stuff yet. I'm just going to start at 3 and go up 1 over 2, up 1 over 2, up 1 over 2. So this is just the regular slope-intercept. And then less than or equal to. So the less than or equal to is the key here. That means it's going to be a solid line, and I'm going to shade below, less than or equal to. So that means I'm going to draw a solid line here. Now, I actually have a nice line tool that helps me with that. You should use some sort of ruler or a straight edge, but I'll keep with the same colors here. So I draw a solid line because I have that equal to. If it was just less than, it'd be a different story. And we put arrows on the ends. And then less than means I shade below it. So I shade everything less than. Now, as far as shading goes, that's a good amount. Some people will shade too much or too little. Too much is better than too little. Like, you don't want to just draw 1, 2, 3 lines and say that's shading. But you also don't want to spend 5 minutes like coloring this all in. That's a waste of time. A good rule is use the graph. Like, I did that one kind of fast, but you can kind of like, use the lines of the grid if you want to, something like that. Or if you want to, go in between the lines and just stay on the boxes, but even that's probably more than you need in most cases. But, take your time shading, but don't think you need to spend a lot of time shading. But this is, all of the points in this region are in the answer. And just like we did linear systems where 2 lines cross, what you're going to say after this, just to preview a second. I guess I don't have the example done up here. But you'll see 2 inequalities, and we want to know where these overlapping shaded regions are. Okay, this is called the shaded region. And sometimes we put a big S in there to stand for it. The solution is this whole thing. Now, in this case, the points on the line would be considered in the solution, along with all the shaded region points. And sometimes there'll be questions where they have you graph it, and then they'll either say, is this point in the solution, or pick a point in the solution kind of thing. So you got to be able to read it. Can you go always plug it in, see if it comes out to be true. Plug in the x and y value, see if it comes out to be true. Like if you get 1 is less than or equal to 5, that's true. If you get 7 is less than 5, it's false. Okay, let's try a few more. So this one, do this one in green. Our y-intercept is -2, and our slope is -3. So that's down 3 over 1. And I'm out of space already, so then I'll go the other way. And see, even now I just grabbed my line tool, but this one you got to hesitate. So greater than means it is going to be a dotted line and above, because it's not greater than or equal to. It's not the greater that makes it dotted, it's the fact that it's not equal to. The equal to bar gives me a solid line. The lack of equal to bar gives me a dotted line. So usually I just hand draw it then when it's a dotted line. I kind of just put slashes through the points that I made. That's usually enough. And shading above. Now again, this may be one of those where it's kind of difficult to tell what's above and what's below, but if I use my y-intercept, it's not too bad. That the y-axis that's above it is up here. So that's where I want to shade. And you'll see sometimes I like to shade vertically, and then there's times where I like to shade horizontally. It depends on the slope of the line for me. The more vertical it is, the more likely I am to shade horizontally. The more horizontal it is, I shade vertically, kind of thing. And you could shade on angles too, but I like to use the boxes. So you notice that I shaded in line with the boxes there. A couple more quick ones. Or maybe I'll skip C since this video is running a little long. I think you probably are doing pretty good here. But the last thing, I want to do D is because it's not in standard form. Again, notice that these were mx plus b, y is alone, y is alone. Here, y is not alone. So I do want to add 2 first. And remember, when you do x plus 2, they can't be combined. They're not like terms. So it just stays x plus 2. And the sign was greater than or equal to. It still is greater than or equal to. I'm not flipping that sign. I only flip it if I divide both sides by a negative. So this one has the y-intercept of 2. And a slope of just 1 over 1. So up 1 over 1, up 1 over 1. And then this is a greater than or equal to. So greater than or equal to tells us the equal to means not dotted. The equal to means we're going to do a solid. And the greater than means we're going to go up. So I can use my line tool now and draw a solid line. And hand draw on the arrows on the ends. Oh, let me go back to green. And the greater than means shade above it. So this one's kind of slanted, so I could probably go either way here. I'll go horizontal. And that's really about it. It's just maybe you got to get it in standard form, get y alone, your slope, your y-intercept. But then the big thing is it a solid line? Is it a dotted line? And which side do I shade? The other thing is if you're really not sure what side to shade on, pick a test point. Like I could pick a coordinate, something easy to work with, like 0, 0. If I plug 0, 0 in here, and I can plug it into my original or this one, doesn't matter. If I plug in 0, I get 0 minus 2 is greater than or equal to 0, which ends up telling me -2 is greater than or equal to 0. That's false. Because it comes out false, I know that's not the side I shade to. If I were to pick a point, say this point, or this point, or this point, or any point in here, it's going to come up to be true, because those are the correct solution region points. So if you're not sure about your shading with the whole above-below thing, pick a test point. If it works, you're in the right side. If it doesn't, it's the other side. All right, that's it for graphing inequalities. See you.